Alright, so today we're starting a new chapter on solving quadratic equations, and it is 2:12:19 today. So the first question is, what is a solution to a quadratic function? So if we graph a parabola, where are the solutions? And we have mentioned before that x-intercepts are also called solutions. So the x-intercepts of the graph or of the equation are the solutions, and a reminder that that would be where the parabola crosses the x-axis. And I might even add on here too that it will be some kind of number, comma, 0, because if you're at the x-axis, then your y number is 0. So how do I solve quadratic functions? We have several ways. Today we're going to do two. We are going to solve by graphing, and we are going to solve by the square root method, or by square roots. So those are today. In our future, we will solve by factoring. So we have factored before, but we haven't gone ahead and solved with factoring. We will do that. We will complete the square, which is a pretty new way. I don't think you'll have seen it before. We will use the quadratic formula, and we'll be introduced to that next week. And the last way is we can find them on our calculator, and we've already done that. We've already been finding x-intercepts on our calculator. So we have a couple of pictures below that are showing us that we can have different options. It might be like the first picture where there are no x-intercepts, so we would say that there are no solutions. Or the second one has only one x-intercept, only one solution, and it is the vertex. That's the only one part that is touching. So I'll put in there that that's the vertex, that is the solution. And then we have often two solutions because our vertex is a little underneath or a little above the x-axis. So these are the most common ones that we've been looking at. Now, it says a lot of words down here. Let's read them together. Finding x-intercepts by graphing is not a reliable method and should be used only when asked, given a graph with clear x-intercepts, or when a close approximation will work for your answer. So it says it more. You need to know where to find solutions given a graph, and that all x-intercepts have a y value of 0. So we've written that above, that we're looking for a number, comma, 0. But they're saying here is that most of the time when we've done this so far, we have used our calculator because they were very messy decimals. So using just a regular graph, not on a calculator, often doesn't work. We will only do this if it's super obvious what the x-intercepts are. The last sentence it mentions is that solutions to quadratic functions are also known as roots or zeros. So I want you to circle for me the word solution, the word root, the word 0, and let's even add the word x-intercept, because all four of these words, when we are talking about a quadratic function, are the same thing. Our calculator calls them zeros. We most often have called them x-intercepts. We're adding that they are called solutions and roots. So let's look at some example problems. So on this first example on the back, we are supposed to find the solutions for these graphs, meaning the x-intercepts. So I see 2 on this first graph. They are painfully obvious with whole numbers. That's why we are doing them from the graph. So my two solutions are 2, 0 and 6, 0. Those are my x-intercepts. Those are my solutions. The next graph, it looks like it only has 1, and it is at the vertex, and it is even labeled 3, 0. Done. So if it is super obvious like that on a graph, why not use the graph? But most of the times it will not be. So another method that we can use is called the square root method. We only get to use this sometimes. So we can use this method to answer the question when the b value is 0. So what I mean by that is, in standard form, when we have our regular equation, ax squared plus bx plus c, the number in the b spot needs to be 0, so there pretty much needs to be no middle term in order to use this method. So we're going to practice this one today below. So we have 3 equations, and we're supposed to solve them, meaning get the letter by itself. So I'm going to draw a line down the middle, throwing it back to a long time ago, beginning of the year when we solved. First thing I would want to do for this problem is add 36 on both sides. So it would say m squared equals 36. Now, we need to figure out how to get m by itself, so to get rid of the square. Now, some of you might be saying, it's 6. 6 times 6, 6 squared is 36. We already know it. But we want to practice our mathematical operations. So the opposite of a square root of a square is a square root. So just like how here there was a minus 36, so we did addition, and it was inverse, so those canceled out. We want to do the same thing here. So we will do square root on both sides, which cancels out the square, so then it just says m, and the square root of 36 is 6, but it's also negative 6, because negative 6 times negative 6 also equals 36. So this is saying that if we graphed this, if we had this on a graph, the x-intercepts for this graph would have been over here at 6, 0, and over here at negative 6, 0. Those would have been the 2 solutions if this was a graph. So let's try this process again for the next ones to find the solutions. We should first subtract 16 from both sides, so it will say 4d squared equals 0. You might think we're done because it equals 0, but we are not. We still need to do our steps. So we need to divide 4 on both sides, so d squared equals 0. And now we need to take the square root to get rid of this square on both sides, so d equals 0. There's only one square root to 0, so on a graph, this must have had a vertex at 0, 0 right here, and that is our solution. That is our x-intercept, 0, 0. So notice the number that we are finding for the solution is the x value in the parentheses. So just like over here where we wrote 6, 0, the number we get for our answer is the x. The y is always a 0. So we've got one more. We need to divide this by negative 2 on both sides. So x squared equals negative 4. And we need to do the square root on both sides. So x equals, we don't have an answer to this. If you type this in your calculator, it will say error. Because if you square a number, it always turns positive. 2 times 2, positive 4. Negative 2 times negative 2, positive 4. There is no real number that will give you a negative 4 when you square it. So this means that there are no real solutions, and that is our answer. So please say no real solutions, because there is this thing called an imaginary number, but we don't need to worry about those. We just need to say there are no real solutions. So on a graph, this would have looked something like this. Ooh, that's a rough parabola, where it didn't have any x-intercepts. It didn't touch at all. So to read our words at the bottom here, it says, notice the directions said just to solve. So we have to understand that there are infinitely many points that can satisfy a quadratic equation. So that's saying there are infinitely many points that would just be on the graph, and those are the ones we see in our table. So I'm putting dots of those. There's tons of them, infinite. But when we are asked to solve, we are finding the x-intercepts, which again could also be called solutions, zeros, or roots. So if you are given a quadratic and just said solve, that means find the x-intercepts. And that's how we will do it for our first two methods to find them.